final panel will focus on the development of a vaccine. I would like to welcome Dr. Fauci, Anthony Fauci, who's the director of the National Institute of Allergy and Infectious Disease, AIDS coordinator for the National Institutes of Health, Dr. David Martin, the vice president for research of the biotechnology company Genentech, and Dr. Samuel Katz of Duke University, member of the expert Institute of Medicine panel on vaccine development. There are many important issues which we must address if a vaccine will be available to the public in time to help protect the world's population from the AIDS plague. And I think that our panel here this morning can provide for this committee and hopefully for the public an update of where we are medically in terms of the vaccine development. We'll start with Dr. Fauci.
Mr. Chairman, members of the committee, I'm here today to discuss the research activities of the National Institutes of Health, the NIH, related to the development of a vaccine for the prevention of AIDS and AIDS-related diseases. I've submitted my written opening statement for the record. I would like now to briefly summarize the salient features of that statement. As soon as it was recognized that AIDS was caused by a specific virus which attacks the human immune system, the NIH aggressively pursued the development of a vaccine to prevent this devastating disease. At the present time, vaccine development research is being supported extramurally by NIH as well as in the NIH intramural program. The NIH has obligated a total of $20,518,000 total from 1984 to 1986 on vaccine development efforts. It is estimated that $26,677,000 will be obligated in fiscal year 87, and the President's budget for fiscal year 88 reflects $42,054,000 for vaccine research. These sums do not include the great deal of basic research funded by and at the NIH that forms the foundation for and that is applicable to vaccine development. In this regard, it is important to point out that the advances we have made toward developing a vaccine are due to the previous investments in basic research and the resulting knowledge gained in the areas of virology, molecular biology, microbial genetics, and immunology. Despite these advances, a great deal of work needs to be done before an effective vaccine will be available. Nonetheless, concrete steps are already being taken in vaccine studies. A number of candidate AIDS vaccine preparations have been made using a variety of scientific approaches. The specific details of several of these approaches and the institutes involved in the execution and/or support of them are described in my written statement. In order to further expand the scope of investigators involved and the types of approaches used, the NIH will establish in fiscal year 88 several national cooperative vaccine discovery groups that will consist of multi-institutional, multidisciplinary research teams to develop creative and targeted approaches to vaccine development. This program will encourage the collaboration of academic and industrial organizations. In addition, as a step toward increasing the NIH intramural capabilities in AIDS vaccine development, an intramural vaccine development unit was established by NIAID in fiscal year 1986. After candidate vaccines have been shown to be safe and immunogenic in the laboratory and in animal testing, they will become the responsibility of the NIAID, the National Institute of Allergy and Infectious Diseases, for clinical evaluation in humans. NIAID currently supports 6 vaccine evaluation units specifically designed to conduct phase 1 and phase 2 safety and antigenicity testing of vaccines in humans. Several of these units will be involved in AIDS vaccine testing and are now preparing for the time when candidate preparations become available. Those units to be involved in AIDS vaccine will be expanded to allow them to respond to this additional need while maintaining their commitments to other important vaccine testing efforts. It is likely that phase 1 studies aimed at determining safety and immunogenicity of a candidate vaccine may be initiated in 1987 or the beginning of 1988. Coordination of NIH scientific efforts in vaccine development is handled through a variety of mechanisms.
I ask you at that, what are the numbers you're talking about that may be tested on?
When you have phase 1 studies, they are, relatively speaking, small numbers. You're talking about hundreds of people, which then in phase 2 go into thousands, and in phase 3, large numbers. Coordination of NIH scientific efforts in vaccine development, as I mentioned, is handled through a variety of mechanisms. There's a great deal of coordination of efforts that occurs through the usual informal scientist-to-scientist interaction between NIH institutes, other public health service agencies, private industry, and academic institutions. The NIH AIDS Executive Committee, which is made up of directors of the NIH components with AIDS research responsibilities, meets regularly twice a month to coordinate administrative, fiscal, and research efforts. The committee is co-chaired by the director of the NIH and myself. In addition, I have established an NIH-wide AIDS Scientific Vaccine Committee made up of intramural scientists actively engaged in AIDS vaccine research. Exchange of information on vaccine development with other public health service agencies is facilitated by the PHS AIDS Vaccine Development and Therapeutic Intervention Subgroup of the PHS Task Force on AIDS that regularly meets. In summary, the NIH has responded to the need for a vaccine to prevent AIDS and AIDS-related disease through the development of a number of basic and applied research efforts, both within its intramural laboratories and through extramural support of academic and industrial organizations. Important advances have been made. However, despite these rapid advances, given the nature of the AIDS epidemic and other considerations, which I will be happy to discuss with you during the question period, even if the preparations now under investigation prove to be safe and effective, it is likely that it will take a number of years until a vaccine is available for widespread use.
Can you just elaborate on that? How many years are you talking?
Yeah. You're talking about from 5 to 8 years. If you talk about phase 1 studies, they go from 3 to 9 months. Phase 2, anywhere from a few months to 36 months. And phase 3, which is larger, widespread, multi-center, controlled trials, will take up to 5 or 8 years. So we don't expect, if we do have a vaccine, that it will be available for widespread use well into the 1990s. This concludes my remarks, Mr. Chairman.
Can we have Dr. Martin, David Martin?
Yes, thank you, Mr. Chairman. My name is David Martin. I'm a physician and geneticist, Vice President, Director of Research of Genentech. With me is Brian Cunningham, who is Vice President and General Counsel of Genentech. Genentech is a leading biotechnology company committed to the research, development, and commercialization of pharmaceutical products made through recombinant DNA technology. Genentech is one of the biotechnology companies actually pursuing development of an AIDS vaccine. I appreciate the opportunity to share with you the promise and the frustrations of our efforts in this area. A major hope in the struggle against AIDS is that development of a vaccine will be possible. The consensus of experts, including those at the WHO and the National Academy of Sciences, is that even if the scientific and non-scientific issues which cloud the development of an AIDS vaccine can be resolved, a vaccine is 5 or more years away. Although a vaccine may be years away, this should not detract from the tremendous strides of the scientific community that you have heard about earlier this morning, nor should it dash any hopes for a vaccine. Perhaps the major scientific obstacle involved in producing an effective AIDS vaccine is the virus variation problem. This problem stems from the fact that there exist multiple strains of HIV, or the AIDS virus, with immunologically distinct surfaces. This enables the virus to evade an immune response because the immune response, for example, one generated by vaccination, which eliminates one type of virus, may be less effective or ineffective in eliminating a virus with a slightly different surface component. A similar situation exists in the case of polio, where there are 3 immunologic distinct forms of the virus. All 3 types of viruses are included in a polyvalent vaccine. This vaccine has been spectacularly effective, and it is obvious that a similar polyvalent vaccine for AIDS might protect individuals against the various types of the virus. Unfortunately, the number of HIV types, that is serotypes, is completely unknown at this time. Federal efforts should support and expedite the ongoing research efforts. First, Congress should provide increasing funding to greatly enhance and fully support the NIH and other governmental and private agencies who are conducting serotyping of the AIDS virus. The same serotyping program which was done for polio is essential for the development of an AIDS vaccine. The technology for this serotyping currently exists. The technology for this, or the results of this typing, will allow the various investigators working on an AIDS vaccine to choose the genes from the appropriate viral isolates for inclusion in a polyvalent vaccine in order to provide broad protection against the different type of AIDS virus. Secondly, we urge this committee to take steps to develop a central repository for viral isolates and patient sera so that they are readily available to all qualified scientists. The powerful tools of biotechnology have much to offer in the development of vaccines, particularly in connection with an AIDS vaccine. Genetically engineered vaccines based on portions of the recombinantly produced surfaces of AIDS viral envelope are inherently much safer than conventional vaccines, which use weakened or killed vaccines. Recombinantly produced fragment merely mimics the portion of the virus in order to trigger an immune response. Absolutely no one will develop an AIDS infection from this type of vaccine. No vaccine, however, is 100% safe. It will not be until after the widespread use of an AIDS vaccine that the infrequent adverse effects will be identifiable. Testing of an AIDS vaccine has its own unique problems. There are no good animal models. Even though the HIV infects certain non-human primates, it does not generate an AIDS in those animals. Only direct test on humans will suffice, and the direct test will clearly raise many social, ethical, and political questions in the determination of whether a vaccine will be effective. Because of the long latency period of HIV in humans after infection, it may take, as Dr. Fauci has said, many years to determine whether it effectively prevents AIDS. The Institute of Medicine conference in March of 1986 found that promising research results are not developed into products because of, number one, the enormous expense of clinical trials, number two, the unknown market size, particularly with adult vaccines, which are not mandated by the states, and number three, the potential for large and unpredictable awards and product liability cases where the manufacturer has probably made a vaccine which has an inherent and unknown risk, one that cannot be avoided. The Institute of Medicine has correctly identified the barriers to vaccine development. The uncertain legal environment has had tangible adverse effects on vaccine manufacturers. It has discouraged the manufacture and innovation of vaccines. Some pharmaceutical manufacturers have chosen to opt out of the vaccine business altogether. The remaining manufacturers have been forced to reflect the increased cost of their prices. They're in their prices. Last fall, when Congress considered the childhood vaccines bill, the number of manufacturers had dwindled from one manufacturer of polio vaccine, one manufacturer of vaccines for measles, mumps, and rubella, and two DPT vaccine manufacturers. In fact, in May of 1986, the two manufacturers of the DPT vaccine announced tremendous price hikes to cover the cost of lawsuits. One of the manufacturers, which had priced a dose of vaccine in 1982 at 11 cents per dose, was reportedly charging $11 per dose after June 1986 to cover the cost of litigation through self-insurance. The same disincentives for manufacturing childhood vaccines exist for developing an AIDS vaccine. In addition, there are other obstacles to the development of an AIDS vaccine. Unlike the childhood vaccines, whose widespread use identified adverse side effects, we cannot accurately know or guess what side effects will be associated with an AIDS vaccine. Unlike the childhood vaccines which the states make mandatory for each child, we do not yet know whether or when the government will make an AIDS vaccine mandatory. The question of who will use a vaccine is critical to answer for purposes of commercialization, but it has even more significant health consequences. From a public health point of view, there are a number of reasons why the government should make an AIDS vaccine, once developed and proven safe, compulsory. First, the most important consideration is that the current epidemiology of AIDS in the United States and its prevalence in the identified high-risk groups, such as homosexual men and IV drug abusers, most likely reflects the transmission of the virus 5 or more years ago. 5 years from today, we may well see an entirely different epidemiologic picture for HIV infection with a much greater prevalence in the general heterosexual population. Indeed, we already know from the epidemiology of HIV infection in Africa that at least certain HIV strains can be spread through the heterosexual population. For this reason, the vaccination of the general population at the earliest possible date is essential to prevent anything remotely similar to the widespread heterosexual epidemic now in progress in several African nations. Secondly, there is absolutely no way to guarantee that the nation's blood supply will remain entirely safe with respect to HIV transmission. Generalized vaccination of the heterosexual population is the only way to reduce the risk that contaminated blood is not inadvertently administered to unprotected individuals. Thirdly, we cannot afford to allow HIV to become endemic in the way that hepatitis B has. Currently, there are over 2 million carriers of hepatitis B in the United States and nearly 200 million in the People's Republic of China. As has happened for hepatitis B, once a significant number of women of childbearing age are infected with HIV, the infection may become endemic because it is frequently passed to the children of such mothers. If we do not intervene now, we may be faced in the future with a widespread chronic endemic infection in a large pool of carriers. And fourthly, generalized vaccination programs were responsible for the remarkable successes of the smallpox and the polio immunization eradication programs, which you heard about a few moments ago. Vaccines targeted at high-risk groups without compulsion, such as the hepatitis B vaccine, have failed to prevent an increased incidence of the disease in the United States. At least one state, California, has enacted legislation to facilitate development of an AIDS vaccine. Last fall, California passed a law, Assembly Bill 4250, which addresses each of the obstacles the Institute of Medicine said would stymie vaccine development. The California legislation is a laudable first step. Federal legislation should go further in the area of tort reform. It should ensure that judges and juries do not have the power to second-guess the judgment of FDA experts who, after spending years evaluating the benefit-risk ratio of a vaccine, will have concluded that the benefit to the public from an HIV vaccine outweighs the unavoidable risk inherent in such a vaccine. Federal law should clearly protect the manufacturers of an AIDS vaccine from liability without fault. For these reasons, we support the following congressional actions. Number one, increased funding for programs directed towards serotyping. Number two, establishment of a central repository of AIDS virus isolates and patient sera. Number three, tort reform to establish fault-based products liability, including a victim compensation fund to discharge society's responsibility to pay for the larger benefit of a population protected against the deadly HIV. Number four, making a vaccine against HIV a compulsory vaccine for the general population. We urge that these steps be taken now when the biotechnology companies developing HIV vaccines are on the verge of making the decision of whether or not to mount the very expensive scale-up and preclinical clinical development programs necessary before the commercialization of their R&D efforts. Thank you.
Given a lot to think about in that testimony, both the ethical issues as well as the liability issues, commercial matters, which we'll come back to. Dr. Katz, we welcome you, a distinguished pediatrician. We're delighted to have you here today.
Thank you, Mr. Kennedy.
Research.
Mr. Weicker, Mr. Metzenbaum, Mr. Adams. This is a special opportunity for me to speak with you about some selected issues which we face in the development and the use of vaccines to prevent AIDS. My own interest in vaccines spans 30 years of involvement with basic virologic research, clinical investigation, vaccine trials, research consultation, and more recently, public policy. Currently, I serve as chairman of the Immunization Practices Advisory Committee of the United States Public Health Service, which formulates the recommendations for use of vaccines in this country. Additionally, Dr. Fauci has asked me to be a consultant to the AIDS Executive Committee of the National Institutes of Health. For several years, from 1982 to 1985, I served on several Institute of Medicine committees which examined priorities in vaccine development at the request of the National Institute of Allergy and Infectious Diseases, and the very interaction to which Dr. Martin spoke of the public and private sectors in vaccine innovation. I think it's important to review briefly the past history of vaccine development in this country in order to look at the current challenge with some perspective. During the past 35 years, we have been eminently successful in developing safe and effective vaccines to prevent a multitude of virus infections, including influenza, poliomyelitis, measles, mumps, congenital rubella, and hepatitis B. These successes have all represented combined endeavors of individual scientists and groups of researchers in various settings: university medical centers, research institutes, governmental agencies, including NIH, the Centers for Disease Control, the Department of Defense, and the Food and Drug Administration, and private industry. The interplay among these individuals and groups has been dynamic, healthily competitive, and in many instances, positive and collaborative. Most of those who attended a July 9 NIH workshop on AIDS vaccine, sponsored by the National Institute of Allergy and Infectious Diseases, left those sessions with guarded optimism but renewed determination to seek effective vaccines for the prevention of HIV infections. It was apparent that much information remained to be acquired regarding many aspects of AIDS. During my earlier statement, I spoke with optimism, but I think it is important to underline what Dr. Fauci has already mentioned, and that is we have no previous experience with the prevention of human infections due to this particular class of agents, the retroviruses. All the other successes which we mentioned are with different types of viruses. In thinking of the directions in which vaccine development would go, it is my best judgment that the most important intervention will be in the prevention of the original infection with human immunodeficiency virus, not in the prevention of disease in those important, unfortunate individuals who are already infected. Their salvage will be better addressed by chemotherapy, immunotherapy, and combinations of both. Even if induced animal infections such as those mentioned in chimpanzees and other non-human primates can serve as models of human infection, it is important to appreciate that retroviruses may behave very variably in different species, so that the requisite transition from laboratory and animal experiment to human study will be critical and fraught with anxiety. The eventual strategies for intervention with vaccines to prevent human infection will be conclusively determined only by studies in man. Thus, there are ethical, legal, and social issues to be considered in parallel with the very complex scientific ones. There are major concerns regarding liability. Dr. Martin has spoken to these. This is an area where government intervention is critical to the encouragement of successful clinical studies. The recently enacted National Childhood Vaccine Injury Act of 1986, Public Law 99-660, could well serve as a prototype for federal and/or state development of legislation to establish an equitable, reasoned approach to compensation and liability for alleged vaccine-related injury. This issue is considered at great length in several recent reports from the Institute of Medicine. To encourage the pharmaceutical industry to develop and to distribute potential AIDS vaccines, the system must be corrected in a way that will remove the current legal interpretation of strict product liability while still protecting vaccine recipients and guaranteeing compensation for any injuries incurred. The planning and implementation of the initial human clinical trials will merit careful scrutiny by an expert advisory group. Such trials will have to be conducted in special settings, such as those which Dr. Fauci described in the vaccine centers. When a vaccine is shown to be successful in generating an immune response, the next steps will be even more difficult. How does one select a group of susceptible individuals at risk in order to assess the prophylactic efficacy of such a vaccine? There will be many issues to be considered, including the aforementioned confidentiality, compliance with long-term follow-up, and the anticipated cost of such studies. Once an apparently successful vaccine has been developed and brought through phases 1 and 2, the question arises again as to at what age and to whom would one administer this vaccine. It will be exceedingly difficult, if not impossible, to identify in advance those individuals whose eventual choice of lifestyle may make them at greater risk of AIDS, or who will be subjected to environmental factors that may put them at higher risk. The question will arise whether this is a vaccine which should be administered to all children, and Dr. Martin has raised that question, early in life, as is now our accepted practice for the common preventable diseases, diphtheria, whooping cough, tetanus, polio, measles, mumps, rubella. The social stigma of AIDS may arouse significant reluctance of parents to have their children immunized against a disease which they cannot envision ever affecting them. However, an ideal age might be age 10 or 11 years prior to or at the onset of observed sexual activity in our society. The issues of funding are obvious, they've been spoken to, and I won't reiterate them. In summary, I believe that the priorities which one can assign to the development of an AIDS vaccine are unequaled by any other disease which we face today or have faced in recent years, so that in the consideration of all of these issues, we can only adopt a positive approach to the development of a safe and effective vaccine and the mobilization of funds to continue and foster the research and development leading to it. Thank you, Mr.
Thank you very much.